Assalamu alaikum. It's a hematology part where I will talk about the RBC morphology and associated pathophysiology. First of all, acanthocytes. Acanthocytes acanthocytes are asymmetric, like acanthocytes also known as sparse cells. It is present in liver disease, abetalipoproteinemia, and vitamin A deficiency. Liver disease, abetalipoproteinemia, and liver disease, abetalipoproteinemia, and vitamin E deficiency. So acanthocytes projections of varying size at irregular intervals. Echinocytes, also known as bar cells, it is also present in liver disease, ESRD, and pyruvate kinase deficiency. This one is very pyruvate kinase deficiency. In pyruvate kinase deficiency, there is echinocytes or bar cells. These echinocytes are even uniform projections, mm, uniform projections, smaller and more uniform projection. Echinocytes, bar cell. Dacrocytes, also known as teardrop cell. Dacrocytes, also known as teardrop cell. It is present in myelofibrosis. It is present in myelofibrosis. So RBC sheds a tear because it is mechanically squeezed out of its home in the bone marrow. Then schistocytes and the helmet cell, fragmented cell, schistocyte, helmet cell, fragmented cell. These are present in DICTTP has help, DICTTP has help, and and if there is a mechanical hemolysis, heart valve prosthesis, these are present in those schistocytes or helmet cell or fragmented cell is present. This one is super high yield. Tegmacyte bite cell G6PD deficiency. You have to differentiate from degmacytes bite cell from bar cell like pyruvate kinase, so BP, and degmacyte DG like degmacytes is a G6PD deficiency. Elliptocytes, hereditary elliptocytosis, spherocytes, hereditary spherocytosis, and autoimmune hemolytic anemia. Autoimmune hemolytic anemia. These two is very high yield, hereditary spherocytosis. And macrovillosite megaloblastic anemia. Target cell is very halt. Hemoglobin C disease, asplenia, liver disease, and thalassemia. And the sickle cell, like sickle cell disease. This is acanthocytes. These are uneven, not but this is bar cell, or this one is like bar cell or echinocyte. It is echinocytes are kind of even. Echinocytes are even. This is the C is degmacyte bite cell. Looks like someone is uh, sorry, dacrocytes. Sorry, it's C is dacrocytes. Looks like teardrop cell, but this one looks like helmet cell, and this one looks like bite cell. E is bite cell or degmacytes or bite cell. Bite cell. This is helmet cell. DICTTP has help fragmented cell, RBC, fragmented RBC. This looks like teardrop cell. F is elliptocyte. This is elliptical, and G is spherocytes, and H is macroovelocyte. This looks like a target, and this is sickle cell. This looks like a target, and this is sickle cell. Now RBC inclusions in the bone marrow, in the peripheral blood smear. RBC inclusion in the bone marrow and the peripheral blood smear. First, granules. Iron granules present in sideroblastic. Another name of the iron, sidero, iron granules, sideroblastic. Sideroblastic animal like lead poison, like myelodysplastic syndrome, like chronic alcoholic overuse. In chronic alcoholic, there may be hypomagnesemia and thus causing hypokalemia. Because if somebody has hypocalcemia and you are unable to correct, and you take the history that he is chronic alcoholic, so do serum magnesium. Okay, iron granule, perinuclear mitochondria with excess iron, forming iron in ring sideroblast, require Prussian blue stain to be visualized. And then the peripheral blood smear, Howell Jolly body, and this is Howell Jolly body is functional asplenia like sickle cell disease and asplenia. Sickle cell disease and asplenia. Basophilic nuclear remnant, it do not contain iron. Body, Howell Jolly bodies do not contain iron. But in sideroblastic anemia, there is forming ring in sideroblast, usually removed by splenic macrophage. Howell Jolly body is usually removed by splenic macrophage. Basophilic stripling, sideroblastic anemia, thalassemia, basophilic ribosomal participate. It do not contain iron. Basophilic, it do not contain iron. Pappenheimer body, it is also the cause of sideroblastic anemia. Basophilic stippling and Pappenheimer both cause are sideroblastic. Basophilic granules contain iron. It contains Pappenheimer bodies contain iron, but Howell Jolly body and basophilic stippling, it does not cause iron. And the Hinge body, G6PD is a Hinge body. In Hinge body, which cell you will got in bite cell? In G6PD, there is bite cell in RBC morphology and in peripheral blood smear. Uh, Hinge bodies. So it is denatured and precipitated hemoglobin. It contains iron. Pappenheimer body contain iron. Hinge body, Hinge ketchup contain iron. Phagocytic removal of the Hinge bodies bite cells requires supravital sign crystal blue to be visualized. First, this is a iron granules. This is iron granules. Look at these iron granules. These are the iron granules. It is and the cause is sideroblastic anemia. B is Howell Jolly body. This is black one is a Howell Jolly body. And third is this is a basophilic stippling. This is the basophilic stippling, and this one is this is basophilic stippling, and this is Hinge bodies. Denatured and precipitated hemoglobin containing iron. It contains iron. Okay.